All right, so let's start with just basic equation solving. So hopefully this is review from Algebra 1. We had to do equation solving in geometry, right? And so this is just your steps of equation solving are make sure you can simplify each side. That may mean distributing a number. That may mean combining like terms or both. And then once each of the sides are as simple as they can get, you're going to move all your variables to one side, all your numbers to the other. So for this first one, I would distribute that -2 first. So I would take this -2, I would distribute it through to this group right here. -2 times A, -2 times -5. Then I have something like that. At this point, both sides are as simple as they can get. I cannot combine any like terms. So I'm going to move my variables to one side, my numbers to the other. I would probably move my variables over here. So I would add that 2A over. It will cancel here, which means I need to move the 12 to the other side. So subtract the 12 over to the other side. And that will cancel the 12. And then once I've done that, I can just add down 10 and -2, -1A, +2A. So A equals -2. And that is my answer here. So for this one, both sides actually need to be simplified. This first one, I'm going to distribute that 2 through. So I have 2 times 8x plus 2 times 8. And then I have that plus 6 there. Distribute the 5 through. 5 times -2x. 5 times -6. Now for this one, I actually have some more that I can do to each side after I've distributed, right? I have like terms on the left-hand side here. So I'm going to go ahead and add that 16 and 6 to get 22. And then I can move my variables to one side. I would move this 10x over. And since I moved the 10x that direction, I would move the 22 the other direction. And once I've done that, I can add down 16 and 10 is 16x. Make sure you bring down that equal sign. And on the other side, -30 minus 22. That should not be there. There we go. I was looking at my 52. I was like, something's wrong there. That's a 2, not a 1. All right. Once I have all my variables to one side, all my numbers to the other, now I can divide. Yeah, it helps to add 16 and 10 correctly. All right, so when you do a distance, rate, and time, you want to set up a chart, rate, time, distance. Carlos and Catherine for this one. Fill in what you know. I know 80 kilometers per hour. I know 6. I know 6. I don't know this. I put a variable there. Multiply across. Determine at this point if you set them equal to each other or if you add them. By the way, if you have this extra, they were this far apart, you're going to add them, right? If they're telling you how far apart they started or how far apart they ended up, you're going to add it. And so in this case, we added it up and then just solved. It says how many pounds of brand X sugar, which costs $4 a pound, must be added to 20 pounds of brand Y sugar, which cost $1 per pound, to make a generic sugar, which costs $2 a pound. So once again, you are going to draw a chart. This is a little bit different. You have one more line, right, with mixtures. So with distance, rate, and time, you really only had 2. You had 2 people, or there and back. Here you have 2 mixtures, and then you have a final mixture. And so you have the 2 things you're mixing together and some dollar or percentage depending on what it is. And then you have a final mixture. And so in this case, I am mixing together brand X sugar, brand Y sugar, and then I want my generic sugar. And they are also doing pounds, so that's how much we did. Then we have price per pound, so price per pound. And then we have the total cost of that particular sugar. And so my X sugar, it says how many pounds. Anytime you see the words how many, what are you going to put there? A variable, right? Do I know how many pounds of X sugar? I don't, so I'm going to put a variable there. Do I know what X sugar costs per pound? I do. It's $4. All right. Brand Y sugar. Do I know how many pounds of brand Y sugar I have? Yes. Must be added to 20 pounds of brand Y sugar, right? So we have 20. Everybody agree? Do we know how much brand Y cost? Yes, it's $1. All right. Now, if I know how much of the first I have and how much of the second I have, and I'm mixing them together, then how many pounds of the final guy should I have? Yeah, those two added together, right? So if I add these up, I should have how much sugar I have, right? If I have 5 pounds of the first guy and 20 pounds of the second guy, I should have 25 pounds of sugar when it's all said and done, right? They want the generic sugar to cost how much per pound? 2, so I know that as well. And then this final column is just going to be multiplying across. So x times 4, I write it like this, 4x. 1 times 20, well, that's just 20. And then 2, anytime you have a plus or minus, you're going to put parentheses. And I know the cost of the first one and the cost of the second one should add up to equal the cost of the final. So I should be able to say that 4x plus 20 should equal 2x plus 20. And once again, I have a rather easy equation to solve. The left is as simple as it gets. On the right, I need to distribute 2 times x, 2 times 20. Subtract my variables to one side, my numbers to the other. And then I should be able to add down and solve. 4 and negative 2, 40 minus 20. When I divide that at x equals 10. In this case, my variable was in the pounds, so 10 pounds. What did the x represent in my chart? Pounds of what? The X brand, right? Is that what they asked for? How many pounds of brand X sugar? I have answered my problem. 10 pounds. All right, so once again, I am going to do a chart for this guy. It is going to look just like the chart I just did as far as how I set it up. So I have 2 things I'm mixing together and a final mixture. And so I need to label it. I have a 40% saline solution. All right. Mixed with a 35% saline solution. And then my new mixture that I do not know yet. We are measuring these solutions in what? Liters, right? So we are measuring in liters. We are looking at the concentration of saline. So the second column is going to be percent saline. And this last column then is going to be liters of saline. And that's how these will always go. How you're measuring it, the concentration or the percentage item that you're talking about, and then the measurement of that item. So how many liters do I have of the 40% solution? According to this, I have 3. We already know the percentage. It is 40%, so I'm going to write that 0.40. How much do I have of the 35%? 2, and we already know that percentage as well. So if I have 3 of the first and 2 of the second, how much do I have total solution of this last guy? If I have 3 of the first and I added it to 2 of the second, I should have 5, right? Doesn't that make sense? I added 3 liters and 2 liters. I have 5 liters, right? Okay. What's the concentration of this? Do we know? That's actually what we're solving for, isn't it? So we're going to put an X there. This last column we multiply across. 3 times 0.40, 2 times 0.35, and 5 times X. All right. Now the liters of the first and the liters of the second of saline should add up to the total. So once again, I'm going to add those. I'm going to say 3 times 0.40 plus 2 times 0.35 equals 5x. 3 times 0.40, you can either get your decimals out or leave it. This is going to be 1.2 plus 2 times 0.35 should be 0.7 equals 5x. Simplify, 1.2 and 0.7 should give you 1.9. And then divide. So you're going to say 1.9 divided by 5. You're going to have to move that decimal over, but you're going to get 0.38. They want the concentration, which is always in percentages, by the way. All right, so when you solve, you're going to get 0.38, but they do want it in percentages. So first, X does represent what I'm solving for here. Move your decimal over 2 places. So you would say the new solution is 38% saline.